Try for yourself to find and simplify the difference quotient for the function f of x equal to 3x minus 4. I've set up the formula for the difference quotient. I would like you to evaluate it for this particular function and simplify the answer as much as possible. Pause the video and try to do it on your own, and then compare your results with mine. The first thing we need to do is evaluate the function. The function takes 3 times the input and then subtracts 4 from the result. For the first term, it's f of x plus h, so I need to evaluate it at x plus h. I then need to subtract from that the value f of x, so I'm going to subtract that quantity, which in this case is 3x minus 4. Notice I put the brackets around there to ensure that the sign will be distributed in a moment. And I divide everything by h. Now I'll distribute the terms through, so it's 3x plus 3h minus 4 minus 3x, and again distributing the minus sign, plus 4. Everything is divided by h. Some terms will cancel, including the 3x's and the 4's. We'll be left with 3h over h. Those cancel out, and I'm left with 3. So the difference quotient for this linear function is always equal to the value of 3. This is not a shocking answer. If I draw the graph of y equal to 3x minus 4, I get a line with slope 3 and y-intercept minus 4. The difference quotient takes the value of this function at 2 different values of x, at x and x plus h. We take the 2 points on the graph at those 2 points, and then we draw the line between them, and the difference quotient calculates the slope of that line right there. Well, that line that I drew between those 2 points agrees with the line that is my function itself, and quite clearly the slope of that line is slope 3, as confirmed by the value of the difference quotient. Try to find and simplify the difference quotient for this function f of x equal to x minus 2x squared. I've set you up here with the formula for the difference quotient. I'd like you to evaluate it for this particular function and simplify it as much as possible. Pause the video, give it a shot yourself, and then compare your results with mine. First thing we need to do is evaluate our function. It takes x, so the input, minus 2 times x squared, so twice my input squared, and I'm just using parentheses here to represent what I'm going to put into the function. In this case, I need to first evaluate at x plus h, so I'll put that into the parentheses. I then need to subtract the value of my function at x, so I'm going to put parentheses there to anticipate distribution of the sign. The value of my function at x is x minus 2x squared, so I'm going to substitute that right into that part of the expression. Everything is being divided by h. I now have a considerable amount of simplification in the numerator to perform, so I'm just going to do that carefully. First term is x plus h. I don't need those parentheses, they don't serve any purpose. I'm going to have minus 2, and I'm going to start to FOIL this binomial here. The first term will be x squared. My outer and inner terms will be x times h, and so I'll get 2 of them. And then the last term will be h squared. We then distribute the minus through, minus x, and then plus 2x squared. Again, make sure you distribute. Everything is being divided by h. Look across the expression now, and you'll see some terms that cancel out. So for example, the x and the x cancel out here. And the 2x squared down here at the end will cancel with the minus 2x squared that I get if I distribute this through. So just writing down the terms that survive cancellation, I have h. And then I've got minus 2, this term here times it, so it'll be minus 4 times xh, minus 2 h squared, and those are the only terms that survive in the numerator, and then we divide by h. In the numerator, there's a factor of h. We'll factor that out. It's h times 1 minus 4x minus 2 times h. Dividing everything by h still. And now that factor of h will cancel, and we'll be left with 1 minus 4x minus twice h. This is the difference quotient of this function, simplified as much as possible. Find and simplify the difference quotient for the function f of x equal to 1 over 3 times x. I've set you up with the formula for the difference quotient. I'd like you to evaluate it using this function and simplify as much as possible. Pause the video, give it a shot, and then see how we do together. First thing I need to do is evaluate my function. It's going to be 1 over 3 times the input, which I'm going to put in parentheses here. For the first term, that input is x plus h. For the second term, I need to evaluate it at x, so it's going to be minus 1 over 3 times x. Everything's being divided by h. To simplify this expression, I could find a common denominator for the two terms in the numerator and simplify that result at first before going any further. So to do that, I'm going to provide a factor of x in the numerator and denominator for this term here to account for the factor of x that's over here. For the other term, I'm going to multiply the top and bottom by x plus h, because that's the factor that's going to be in this term here that this other term is missing. Then everything is being divided by h. Let's perform the subtraction in the numerator here. So it's going to be x minus 1 times x plus h, so minus the quantity x plus h when I subtract the numerators. They'll all be over the same denominator, 3 times x plus h. 3 times x plus h. And everything is being divided by h. Now we're going to clean up that numerator. It's going to be x minus x, so they'll cancel out, and then distributing the h through will give me minus h. Everything is over the denominator 3x times x plus h. And all of that is being divided by h. I now have a ratio or a rational expression here that's being divided again by another factor of h. So if I want to take this and divide it by h, I can just multiply by the reciprocal of h. So that factor of h, here's my numerator, whole expression there, and I'm just going to multiply by 1 over h instead of dividing by h. So that agrees with that factor there. The h's then cancel out, and I'll get minus 1 in the numerator. In the denominator, I'll have 3x times x plus h. And this is the difference quotient for 1 over 3x, simplified as much as possible. We'll give an alternative solution to the problem from before. F of x is equal to 1 over 3x. And we'll evaluate the difference quotient by clearing the fractions as opposed to doing the subtraction in the numerator first. So we'll have the same expression when we evaluate. But instead of performing this subtraction first, what we'll just do is clear the fractions by multiplying by enough stuff to cancel out 3, a factor of x plus h, and a factor of x. So I'm going to multiply the top by 3, by x, and by a factor of x plus h. If I do that to the top, I have to do it to the bottom as well to keep things balanced. I'm now going to multiply this expression times this term and times this term. In the denominator here, we'll have h times the factors that we put in the denominator. We have chosen this expression so that every factor in one of these ratios here will cancel out completely. The 3's will cancel, and in the first one I'll have x plus h cancel, but I'll be left with a factor of x. In the second term, 3x will cancel with the 3x here, and I'll be left with this x plus h. And it'll be minus x plus h from the minus sign here. Make sure you have parentheses around that because that's the entire expression that's being subtracted. In the denominator, now just as before, x minus x will cancel out, and I'll have minus h left over. Now the h's will cancel out completely, and I'll get minus 1 over 3x times x plus h, and this is the same result that we saw in the previous example. Find and simplify the difference quotient for the function 1 over x plus 3. I've set you up with the formula for the difference quotient. Pause the video, give it a shot, and then see how we do together. First thing we need to do is evaluate our function. So I'm going to take 1 over x plus 3. Well, that's the function, so I need to put for the input here x plus h for the first term. I then need to subtract from it f of x itself, so I'm just exactly as it appears here, I'll subtract 1 over x plus 3, and then we'll divide everything by h. Cleaning up a little bit, I don't really need those parentheses. And I'm going to multiply the top and bottom of this by x plus 3 in anticipation of getting a common denominator. In the other term, I'm going to multiply the top and bottom by x plus h plus 3, again in anticipation of getting a common denominator for the numerator. Everything is being divided by h, but to save some space here, you might instead immediately write that as 1 over h. Again, dividing by h, same as multiplying by its reciprocal. And you could do that at any point. Notice I have the brackets so that that 1 over h is being applied to the entire expression. I can now multiply and do subtraction here. So 1 times x plus 3 gets me x plus 3. And then minus 1 times that gets me the numerator. All of that is over the common denominator, x plus h plus 3. That's one of the factors times x plus 3. And I'm just going to leave that completely factored like that. There's really no reason to multiply that stuff out. All of that's still being multiplied by 1 over h. I've got x plus 3, then minus x minus h minus 3, distributing the minus sign. And I have my factor of h that I'm just going to bring under the common division here. The x's and the 3's cancel in the numerator. I'll be left with minus h. And that minus h, a factor of h, will cancel with the 1 in the denominator, giving me minus 1 over those two factors. And now we've found and simplified the difference quotient for this function as much as possible.